Hello everyone, my name is Jeffrey Ortiz and I will be walking you through the Sunpetal tower assembly that we've made so far as part of our IED Team Project first status update. So what we have right now is a base assembly and a center panel assembly upon which we will have extended petals that will also supplement the rest of the power generation that we have planned in mind. So, to begin, I'll show you the features of the base assembly. What we're working with here is a 15 feet tall base made out of copper reinforced aluminum, making it weigh about 1,300 pounds. If we look at it through a cross-sectional view, if NX will, we've designed a simple mechanical locking mechanism for the panel base displayed up here to simply fall down, turn, fall down again, and then end up rotationally unconstrained so that the top panel can actually rotate freely using the motors that we plan to install. Here's the peg that we'll be locking in. Now you may notice these holes right here, and the purpose of these features is to allow for further components to be installed. Down the center, we will be installing a lightning rod that extends down through here, will sit on a body here. And then the wiring will either go through this conduit until it is released underneath whatever components we install here, typically a battery for storage. And then it will be released into the ground for redirection of potentially damaging lightning strikes. For benchmarking, there are other models of lightning towers that actually have the wiring exposed on the outside, and I personally think that if we're using a battery, perhaps a conduit that is only this far away from the battery, redirecting a lightning strike amount of current would not be necessarily the safest conclusion. However, with my team, we will be researching forms of insulation that allow that to be a possibility. This second hole that is off center here, you will see actually extends all the way up to the top. Now, this gap right here is 1.6 inches thick, which is, according to some standards, the thickness of a solar panel that is highly efficient. There are other models that are 1.25 inch thick, but in order to allow for the most room, I've decided to model it as such. These 8 hinges will allow for 8 petals to be installed. And the way they will work is that, say we have incident sunlight from this angle, if you see my cursor here, well, we can have the petals that are attached right here move in counter to that and absorb light from here and be angled downward here in order to capture light. And instead of actually tilting the whole assembly, we can simplify the actual constraints of motion and simply have one part of it lift up and the other part of it lower down. When we install lights on the body, we will have mirrors that will allow the light that is being ejected from here to be concentrated down to the street below without having to use a vast amount of lights themselves. If we go through a cross-sectional view of the entire assembly, allow me to produce one, we will see that all of these connections line up. When we have wiring coming down here, we will have enough space to add slack in order for the rotational motion of the body to not disconnect the solar panel's output. In addition, this path will freely allow the lightning rod to exist without interference to the solar panel or any of the other components within. Allow me to rotate the part in question here. Recreate this section, apply it, and then move that component. Start it from the front, zoom in. And so, if we were to rotate this body, and I wish I could demonstrate this at a slower rate. Here we go. That's a much better view. We can see that it is a hollowed out body that allows for the pedals themselves to connect on the inside and be manipulated by a motor that we would fit inside of this chassis here. For what it's worth, this is what the locking mechanism would look like on the interior when it's being manipulated. It's a tight fit, and the only way it can go up is if it's angled properly with this exposure here. And with the gap fitting almost perfectly here when it's in standard position, you can see that that is where our cable path would take place. And thank you. That, for now, is all that we have. Soon, we will be adding a pedal design and electrical components that allow us to more properly estimate the power generation of this model and benchmark it in comparison to other models on the market. Thank you so much for your time. Stay safe and have a good day.